In this video, I'm going to show you how to carry out an analysis of variance test, or an ANOVA test, with a post-hoc test as well. I have the NIS lab dataset open, and I'm going to test education, so educational attainment, the number of years of school completed, and I'm going to test it across visa categories. There are 5 visa categories: family, employment, legalization, refugee, and diversity. They represent different types of migrants, and so I suspect there will be some differences in educational attainment based on the type of visa they use to come to the United States. So to carry out an analysis of variance test, you're going to go to Analyze, and then down to Compare Means, and then over to One-Way ANOVA. One-way just means that we're going to have one independent variable and one dependent variable. So in this case, our dependent variable is going to be years of school completed, and our factor variable, or our independent variable, is going to be visa category. Now, unlike with a t-test, you don't have to define any groups, because with analysis of variance, you can use as many groups as you want. I'm going to select a post-hoc test as well. There are a number of them, and they all tell you essentially the same thing, but Duncan's is probably, in my opinion, the easiest to interpret. So I'll click on that, then I'll click Continue. So the thing about analysis of variance is the hypothesis test itself will tell you whether or not at least one of the means is significantly different from the others. But it won't tell us which mean is significantly different. For that, we have to run this post-hoc test, which is why I just set that up. So we've got all that. We'll click OK. And we get, these are the results of our analysis of variance test. We have our between group variation, we have our within group variation, we have our total amount of variation. And if we wanted to, we could actually work this out by hand. We have our degrees of freedom between, our degrees of freedom within, our mean square between, our mean square within, and we finally get our obtained F statistic, which is 359.953, which is a fairly large F statistic, generally speaking. The box that we're most interested in, however, is this SIG box right here, SIG period. Very much like with the t-tests that we ran, if this box, if the value here is less than 0.05, it means that at least one of the groups is significantly different from the others. So essentially all analysis of variance tests have the same null and research hypotheses. The null hypothesis is that all of the means are the same, and that the research hypothesis is that at least one group is different, or at least one mean is different from the others. So because this is 0, which 0 is less than 0.05, we can reject the null hypothesis, which states that all the means are the same, and we can conclude that the research hypothesis is more likely, that at least one group is different from the others. But again, it doesn't tell us which. So for that, we need to scroll down to the results of our post-hoc test, which was Duncan's post-hoc test. The reason why I like this one is because of the way it sets it up graphically. So if a mean is different from the others, it will be put in its own column. And if two means happen to be the same, or there's no significant difference between two means, then they end up in the same column. You can see here that every group mean has its own column, which is essentially telling us that every single, that the mean educational attainment is different across all 5 groups. So there are no groups where the mean educational attainment is the same, essentially, is what it's telling us. Let's just pretend for a second that the legalization group were the only group that's different from the other 4. In that case, Duncan's post-hoc test would display the legalization number all by itself, 8.89 all by itself, and then all the others would be in the same category, which would essentially tell us that this one is different, but the other 4 are all the same. But because, again, all 5 are in their own column, it tells us that every single one is different from all of the others. Let's do another one just so you can see what it looks like when there's some different results as far as the post-hoc test is concerned. So again, I'll do analyze, and I will do compare means back to one-way ANOVA. Let's get rid of years of school completed, and let's do church attendance per week, and then let's factor that again by visa category, because I think there are some differences there. Let's just check to make sure, yep, Duncan's is still checked, so we're good there. Then we'll click OK. So here we have, again, our results, our obtained F statistic, and our significance box. So that's 0, which essentially tells us that at least one mean is significantly different from the other 4. But again, it does not tell us which mean. So we scroll down, and we can see that the diversity in the family categories ended up in the same column. So that's what's essentially telling us, what this is telling us is that these two together are significantly different from the others, but they're not significantly different from each other. Same thing for legalization and employment visa categories. Their mean religious attendance is different from family and diversity, and it's also different from humanitarian, but they're not different from one another. And humanitarian, that's all by itself, which tells us that it is significantly different from all 4 other categories, which you can see it's almost twice as large as any other category. So that's ANOVA. You don't really need to worry about this stuff here at the bottom. It's just maybe something we'll get to towards the end of the semester. Again, if you have any questions, please let me know. Otherwise, good luck.